Hello everyone. In this lecture, we are going to discuss this topic of impact of jets when the plate is moving. So, if a plate is kept normal to a jet and it is free to move in this direction, and suppose the velocity of the plate is uniform and is given as u, the magnitude of velocity is u, and velocity of the jet itself is v, then the charge will be A into V, where A is the cross-sectional area of the jet and V is the velocity of the jet. Then the volume of fluid hitting the plate per unit time will not be equal to the Q or the discharge, but it will be somewhat less, where A, the cross-sectional area, will be multiplied with not the velocity but the relative velocity between the jet and the plate, because the plate itself is moving. So therefore, if we consider the plate as the reference, then the relative velocity will be v minus u. That means the plate will experience that the fluid is hitting it at a velocity v minus u. So this is the volume of fluid hitting the plate per unit time, and therefore mass hitting the plate per unit time will be, simply multiply that with density rho, and therefore momentum of fluid hitting the plate per unit time is that mass per unit time multiplied by the relative velocity v minus u, and therefore rho a v minus u squared. So this is the momentum of fluid hitting the plate per unit time. Also, the direction has to be mentioned here, which is in the normal direction. After that is after hitting the plate, the water will be deflected in the perpendicular direction, that is by 90 degrees, and therefore the velocity of water after hitting the plate will be written as 0, and this 0 is with respect to the plate. Why do we have to mention with respect to the plate? That's because if we consider the plate as the reference, that means suppose we are moving along with the plate, that is we the observers are moving along with the plate at the same velocity u, in that case we'll see that the water which is moving away will have 0 component in this direction, that is direction of the jet. However, in absolute terms, the velocity of this deflected water will also be equal to u. That means it is moving along with the plate like this. But since we are considering the reference as the plate itself, which we have also done in case of the relative velocity, so therefore we can write that this velocity is 0, and therefore our calculation becomes easier. Change of momentum per unit time is the initial momentum minus the final momentum 0, and therefore the force is equal to this quantity, and we can write as F equals rho a v minus u whole squared. So this is basically the concept of finding out the force acting on a moving plate, where the plate is moving in the direction of the jet. If the plate was moving in the opposite direction of the jet, then this u would be minus u, and therefore in these formulas, instead of v minus u, we will have to write v minus minus u, and in turn it will become equal to v plus u. That means the force will be even greater, and that's quite obvious. If some water is hitting the plate in a certain direction, the plate is trying to move in the opposite direction, obviously the force will be much greater. So this is how we get the force acting on a plate which is moving. There can be some other cases as well. where the impact of jet on inclined plate moving in the direction of the jet, which is, if the jet is moving in this direction, it is hitting in this direction, and the plate is also moving in this direction. So we have already derived what the force will be if the plate was stationary, and in the same formula we only have to replace v with v minus u, where u is the velocity of the plate. Now if the plate itself was moving in some other direction, then you'll have to consider its component along the direction of the velocity, and then try to find out the relation for the force. Sometimes may be the case that the jet is striking a plate which is curved, and that is also moving at some velocity u maybe, and you try to find out what the force will be in that case. And a curved plate may also move in some inclined direction. It may be any angle like this, or in normal direction, or even opposite. So in all these cases, maybe in any other direction. So you try to find out the relations for all these 4 cases. So I'll leave you some assignment problems related to these derivations as well as some numerical problems. Thank you.